Hey guys, in this video I will show you how you can turn curve objects into brick walls with Blender geometry nodes. And of course it's a completely procedural setup with many different cool techniques I haven't seen in any other setup yet. So yeah, let's get started. So let's start with a fresh new Blender file. First I delete everything, then I switch to the geometry nodes tree, and then I add a ground plane. I scale it up a little bit, and next we can choose a curve type to work with. In my case I choose the Bezier curve, but you can work with any other type of curve and even create your curves directly in the geometry nodes tree. And the Bezier curve has the advantage that I can switch to the edit mode, and then I can choose the draw pencil, and in the tool settings I can switch it to surface, and now I can draw my curve directly on the ground plane. And of course I can edit the curve and, for example, delete the two default points. So we have this nice curve which we can turn into a brick wall. And for now I disable the ground plane because I don't need it and I can see the curve a little bit better. And now in object mode I can add a geometry node tree to the curve. So the basic idea here is to split our base curve into segments and then create another copy of this base curve with a slight offset in segments. And then with these two curve objects I can create a vertical array which can then be turned into bricks. But before we start, let's first edit our curve object. So you can see it has these round corners here, and in my case I want it to be straight and have sharp corners. And a way to do this is to simply choose the set spline type node, and by default it is set to poly, and that's exactly what we need. So now you can see we have these sharp corners here. So now that we have our curve object ready, we can start with the main work. So the first step is to cut our curve into smaller segments. And we can do this with the subdivide curve node. And to split it up, we need to first convert it to a mesh, so curve to mesh. And then we can use the split edge node. And if we now take a scale elements node, we can set it to edge and scale each of these edges down a little bit. And the problem we have right now is that the subdivide curve node doesn't distribute the points evenly on our curve object, and this results in segments of different lengths. So for an even distribution of points, there is a little trick where we split our main curve object we have here. So we need a curve to mesh node again and a split edges node. And then we convert these edges back to a curve, so mesh to curve. And now we have our original curve split it into its segments. And now we can get the length of these segments with the spline length node. And if we plug the length straight into the subdivide curve node, we can see that the distribution now is somewhat even. And if we take, for example, a multiply math node, we can change the amount of subdivision here. And for now we want a pretty high resolution, so maybe put this at 5. And we actually don't want to use the scale elements node here, we want to use another method, so let's delete this. And here we have our splitted up edges, and we want to turn it to a curve, so mesh to curve. And then we can use a trim curve node. And here we can trim from the start and from the end of our curve segments. And to do it evenly, I create a value input, which for now we put at 0.05, for example. I can put this straight into the start, and to trim the same amount from the end, I use a subtract node and subtract this value from 1. And now I can evenly trim from the start and from the end. So far the result looks really cool, but remember, we want a copy out of this curve with a slight offset and segments. And a way to achieve this is to delete every second point on our original curve, and in our copy we want to offset the deletion by 1. So first start with the main curve, and here after our subdivide node we need a delete geometry node, and to delete every second point we need the index of each point with the index node, and then we need a modulo node. And if we set the modulo to 2, we can use this for the mask input here, and now every second point gets deleted. The problem right now is that we have these gaps here at the corners, and a way to fix this is to exclude the endpoints from the selection here. So we need the endpoints. We can get these with the endpoint selection node, and now we can simply subtract it from our original selection. Next, I'd like to merge these segments here, but only at the corners, so that our bricks are going kind of like around the corner. And for this I need a merge node after our split edges. And by default it merges all of our points, but of course we only want the endpoints. So to get these endpoints we can use the captured endpoints after our subdivision. So we need the endpoint selection node again, and a capture attribute node. Set it to Boolean, and if we use now the endpoint selection for the selection mask for our merge by distance node, only the endpoints, so the corners, are getting merged. So right now we are basically done with the first curve, and to create the copy with the offset, I take everything after our capture attribute node and duplicate it. Of course we don't need the group output. And now if I simply add 1 after our index, we have the same object only with an offset. So if I look at the difference now, you can see that this is exactly what we want. The next step is to create an array out of these two curves. So I create a vertical line, a mesh line for example, and an instance on points node. And to alternate between these two curves, we need to turn these into instances with the geometry to instances node. And here I plug in both of these curves. And if I use this for the instance input on the instance on point node and toggle on pick instance, it should alternate between these two instances. And maybe we can see it better if I lower the offset a little bit. Yes, you can see it works nicely. To optimize the setup a little bit, we can select all of these nodes here after our delete geometry nodes, because this delete geometry node is what differentiates our two curves from each other, and do this operation after our instance on points node. So I create first a copy out of these, and then I plug this in here and this in here. And it's important that we realize our instances. So realize instances. Then I take our captured endpoints from here. So let me make this long connection to the merge by distance node here. And now we should be able to delete all of these nodes here. And yeah, it still works. And now we do this operation here only once. And this has another advantage. Right now we can use a random value for each of these curves to trim it. So if I take, instead of this value, a random value node and maybe put 0.02 in here and 0.1 in here, every one of these segments has an individual trim value. So they all have an individual gap. And now the easiest part is to turn these curves into bricks, and this can be done with the curve to mesh node. And for the profile curve I use a quadrilateral, and then with a set radius I can change the size of these bricks, and of course we need to toggle fill caps. And now I only need to adjust the gaps here a little bit, maybe like this. And also I want to shade everything flat with the set shade smooth curve. Okay, this looks kind of cool. Right now all of these bricks are really sharp at the corners, and I want to add a little bit of bevel to them, and this can't be easily done with geometry nodes, so I use the bevel modifier for now, and then I adjust some values here, and now we have this nice bevel effect. Now our setup already looks like a brick wall, but I want to add some more features, especially a little bit of randomization. So for example, a random position for each brick, a random rotation, and random scaling. So back in our geometry nodes tree, we need to select the modifier again. The first thing I'd like to do is to do the random position. And for this I go right here after our trimming of curves. So we have these segments here again, and to set the position of these I can use the set position node, and for the random effect I use a random value, put it to vector, and what I like to do is to set it in the range of -1 to 1, and in combination with a vector scale node I can nicely control the offset. So you're seeing what's happening, and you can leave it at that if you like it this way, but remember the random value is based on the indices of each of these points on these curves, but in my case I want it to be based on the index of these curves. So each of these bricks has an individual index, and the way to do this is to capture the index of these curves here. So we use a capture attribute node, set it to spline, and the index is an integer. And then we can simply take the index, put it in here, and use this for the ID mask. And by the way, I am working with Blender 3.2, and I guess in 3.3 there's a special node, so we don't need to capture this here. I think it is called attribute in context or something like this. I'm not really sure right now. And yeah, this does the same thing, so we don't need this kind of complicated setup here. Yeah, anyways, the difference now is that each of these bricks has an individual offset. So without the spline index, it looks like this. So we kind of have the rotation and the scaling in one. And with the index, we have like this cool effect. Can be used for a dissolving effect or something like this. Yeah, but this is our random position. And similarly, we can do the rotation. So for this, I use another set position node. And to rotate the position, I need a vector rotate node. And I want to rotate the original position, so I need it here right now, the position node, plug it into the vector input. And if I put it in the position here, I can switch this to Euler. And right now I should be able to rotate everything. But you can see that the rotation happens around the origin of our object, but we want the rotation to happen around the origin of each of these bricks. And we can get it quite easily, similarly to what we've done here, by capturing the position of each of these spline segments. So we need another capture attribute node, and we do it after we set the position here. So capture attribute, we can leave it at spline, but we need to change it to vector. And then we need a position node again. And now that we have this captured position, we can use it for the center input of our vector rotate node. And now if we look at the result, when we rotate, each of these bricks gets rotated around its own center. To randomize the rotation, we can simply copy the setup we have here with the index already connected and plug it in the rotation input here. And now I change the seed a little bit, and with the scale we can control the amount of random rotation. So I leave it at a pretty low value, so it doesn't is too extreme. Maybe 0.02. Yeah. And now the next is to randomize the radius here. So this is kind of like the scaling of the bricks. And you might have guessed that this is really simple. We can simply copy the random value here again with the index connected. And I changed this to a float. And again, I map this in the range of -1 to 1. And here I simply use a multiply math node. And this is like the amount of random scaling. And then I add this onto the radius I have here. So I need an add math node. And I simply put the same value in here. And I add this on top. And with this I can kind of like control the amount of random scaling. And of course I want it to be a really small value. I changed the seed again a little bit. And maybe the random effect now is a little bit extreme, but I like it this way. And yeah. So really the last step I want to do is to create a nice material for this. So let's open a shader editor. And here I create a new material. I call it bricks. And I also want to set the material to my object. So I need the set material node in my geometry nodes. Then I choose the bricks material. And right now, if I switch this to shaded view, I can see my material changes here, yes. So, of course, I want a little bit of environment, so I toggle my plane back on, and I want to add a light, sunlight in this case. I angle it a little bit to have these shadows. And for the shadow resolution, I increase them a little bit. And also what we can do is to change the clipping a little bit of my viewport to make them even more crisp. So I think 100 meters is okay. And now we have nice crisp shadows. I also want to toggle on ambient occlusion for now. And in the light settings I can turn on contact shadows. Maybe it isn't necessary, but yeah, okay, better with. Okay, so now I want to give each of these bricks a different color. And this can be done with attributes. So I simply capture an attribute here and send it to my shader. And for this we can use the store named attribute node. And we want to store a color, but we can use vector instead, because a color is a vector because it consists of 3 different components, R, G and B. And a vector would work also, so we work with this instead, and we choose a random value here for the input, set it to vector, and it needs to be in the range of 0 to 1, so we leave it at default, plug it into the value socket, and then we give it a name. In my case I name it random color. And right now I can go in my shader, and with the attribute node I can get this attribute. I simply have to type the same name in here, random color. And now we can see that it is working. But there is this problem that each of the indexes of my mesh gets an individual color value, but I want it to be consistent for each of these bricks. And a way to fix this is to simply get the already captured attribute for each of these bricks we have here and put it in the ID input of the random value node. But we can also use the mesh islands node, which gives an index for each of these islands of connected vertices. So in this case a brick. And this gives us the same result. Yeah, but I like to work with the captured index because we already have it. And there you go. So right now I want to adjust the material a little bit, and we can use this value here to give each of these bricks a different color, but there is a more useful thing to do with it, in my opinion. And for example, if we take a noise texture and map it onto our object, then we need a texture coordinate node. Then we use the object output for the vector. And here you can see that the mapping kind of looks weird because it is spanning across the whole object. And that's where our random attribute is coming in. And if we, for example, add this value to our object coordinates with the vector math node, we can give it like a little offset. And it is more visible if we take a vector scale math node, and if we put it at 0, there is no offset happening. And if we increase it, you can see that the offset is started happening. And now each of these bricks has an individual mapping for the noise. And this is a really useful thing to do. Okay, so now I want to use this to do some color mixing. And this is really trivial. I just make a very simple material for now. So maybe give it an orange look for the first color, and the other one a little bit darker and more on the red side. Yeah, like this. So now we are basically done with the main setup, and we can test it by switching back into edit mode. And here we can draw some more walls. And so for example, a straight wall or a corner, and even closed loops should work. So let's try this. Yeah. But remember, because we are using the setSpline type node set to poly, these round objects won't work. So if you want round objects, you have to set it to Bezier. And then you can create like these tower-like structures, but it gives us these problems here on these corners where we want it to be sharp. So you have to choose what you want to do. In my case, I set it to poly again. Of course, we can use procedural curves. So for example, I can use a string to curve node. And if I plug this straight in here, nothing should happen. But if I type, for example, bricks, you see that something is happening. And maybe I need to scale this up a little bit and set it to centered. And I also want to resample this. Yeah, this looks okay. And now we have this nice procedural type generator. Yeah, nice. Okay, anyways, the last step is I want to create some group input nodes, and you can skip this step or do it by yourself. But maybe it is nice to go over the whole setup again and organize it a little bit. So this here is our input. And I try to name everything accordingly. And here we have the base segment splitting. And so let's call this base segments. And with this multiply node here, we can control the length of our curves. So let me choose a better angle. You can see it. So we can create a group input. And this controls the length of our bricks. So brick length. Now I can control it here in the modifier directly. And the next thing here is our endpoint that we captured. So I call this endpoints. Then here we have our two base curves. So I call this base 1 and this is base 2. And then we have here our main instancer line. So let me call this simply instance on points. And here we have these parameters like the count, which is the height of our wall, or the vertical count. So I can create another input for this. And I call this vertical count. And also with the offset here, with the Z value, I can create the vertical offset. So I can create another input for this and call this vertical offset. Yeah. Nice. So here we have the splitting of the segments and also the merging of the corners. And I won't use a special frame for this. Next we have the gap control. So let me call this gaps. And remember, I use the random value for this, but for this case, let's keep it simple and use a singular input and call this input simply gaps. Put it in a frame. And here I can control the gap amount. Next we have our captured brick index. So I will call it brick index. Here we have our random positioning. Let's call it random position. And it would be useful to have an input for this. So take a group input node. And this gives us the random position amount. Oh. And also I want to create an input for the seed for this. So like that. And next we have the setup for the random rotation here. This is our captured position and I included in a frame for the random rotation and I name it random rotation. And here we can take another group input node and I plug the seed value in here and just make a little bit more space. And to give it another seed as this random value here, I simply add a generic number to it, so like that. So these both random values don't have the same seed value. And also I want to control the amount of the rotation, so I create an input for this and I name this random rotation amount. And next we have the random scaling or random radius. So put a frame on this and name it random scale, and then again group input. Here we control the overall scale, and here we control the randomness of it. So these are two inputs. One is the scale and the other one is the random scale amount, and then we have another seed value, and again we add a generic number to it. So I put 12 in here, use the seed like this. Then we have the curve to mesh, and I simply name it CTM, and you can control the depth of the bricks here. So you can use or create an input for this, but in my case I won't. And you can also create the height, and this is already also interesting if you change the vertical offset. So if I change this, I can also change the height here, but you can figure it out yourself. Here we shade it to flat, and here we have the random color attribute. So let's call this random color, and we want to create an input because we need a seed, and we add a value for this. So this, yes. So yeah, that's it for this tutorial. I hope you've liked it and have fun creating some really cool brick walls.